Hello, everyone. So in this video, I'm going to talk about the AMC 2024 problems. So let's get started with the first one. But before we get started, so all the question I'll try will be my first attempt. So if I see another way or maybe a slick approach, so I'll try later on and maybe. But if you do have some other ways, another like kind of approach, just share with me. Okay. So I'll see what we have for the some of these questions. So we are looking for the unit digit of this arithmetic. So we have a lot of subtraction. So everything except the first number has a minus. So maybe I can just take that minus as a common factor. So this could be written like um, a plus because it will be a bit better to deal with that, and that will give us 2, 2, 2, 22, and plus 2. So if I add all of these and whatever I get from subtract from this, I will get my answer. But just don't do the silliest task because what we care about the unit digit, right? So if you add the unit digit, so we have 1, 2, 3, 4, 5, and 6. Like if you just write it like all together and then add it, so you will get 6 of those 2's as the unit digit if you want to add those numbers in parentheses, which is 12. So which is like whenever you add all of these numbers, you get some digit at the end. There will be a 2. Okay, so that is the number you are going to get in parentheses. But before the parentheses, we have 2, 2, 2, 2, 2, 2, right? So if I let me see, double check. 1, 2, 3, 4, 5. Actually, 5 of them. So this wasn't the case. So I have to be careful. So like we have like this one. Maybe I should take this out of the way. Even though it's the first question, it's really important for us to be careful. So that is like this is my last digit. 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 Since we have 5 numbers that has a negative sign, so 5 of those 2's will be added together at the end. So which is going to give us a bunch of digit, and the last digit will be 0. Okay, so that is something. And then the previous number we are given is 6-digit number. So this is the case. If you subtract something that has a 0 at the end from 2, so you will get last digit of that difference will be 2. And that is the answer. So I think that's good. So we can move on to the next question. So the second question, we have a division problem. So value of this expression. So 44 and 11, I can divide by 11. So that should be 4 and 1. And I can divide this by 11. So that should give us 10. Divide by 11, that will give us just 4. And divide by 11, 11. So you will get 100 and then 4. So let's go ahead and write it. So 4 divided by 1 is just 4. And this is like 5 over 2, which is 2.5. And then 4 over 100 is 0.04. So 4 and 2 is 6, 6.5. If you add 6.5 to this number, so you will get 6.50 and 0.04. So that will give us 6.54. So be careful. So I think that is my answer. That is also straightforward. So just kind of divide those carefully. So that's what they ask. The number 3. So there are 4 figures. Side lengths are given for 7, 9, and 10. And arrange increase in size order so that the left edge and the bottom edge are aligned, okay? And the square alternate in color, white and gray. And we are looking for the area of the visible gray region. So like this shaded region and this shaded region. So like this is common type of the question. So you can just take the couple different approach, but one of the things is I can find the area of that square and subtract area of this smaller one to get this first shaded region. So I'm gonna call this is A. So that A is gonna be, so the area of this square is 7 square, and minus area of the smaller one is 4 square. So that's gonna be the region A. And using the same logic, so if I wanna find this region as like B, so the area of the largest circle is like 10 by 10, which is 10 square. minus area of the second largest square, which is like this guy needs to be subtracted, which has a side length of 9. So that's 9 squared. Since we have only 2, you can just go and find their values, which is not going to be too challenging. Or if you have more of these, like shaded region, like maybe 20 of them stuff, you could have just write them and see if there's a cancellation. But now we don't need that part. So that's 49 minus 16. And that's 100 minus 81. That's just 19. And if you subtract 16 from 19, because we're going to add all of these, that's 3. So plus like 49. So that looks like my answer is 52. Okay, so I think that is the answer. So number 4. So the person, Yunji, I guess, added all the integer from 1 through 9, but she mistakenly left out a number. And her incorrect sum turned out to be a square number. What number did she actually leave out? Like, this is kind of straightforward as well. So you have numbers 1 to 3, like all the way to the 9. And if you add these, you can just go ahead and add them. You can pair the first and the last and stuff, or you can just use the Gauss formula, which is 9 times 10 over 2, which is 45. So when you add all these integers, you should be getting 45, but we are missing one of these numbers. And then when we take that missing number, the result is also a perfect square. So if you look at the previous perfect square, like 49 is larger than this, so 36 is the largest perfect square that is gonna be close to this number. So in order for us to get a perfect square, which is 36 for the sum of the remaining 8 numbers, we should decrease 45 by something to get 36, which is basically 9. So mean that the 9 has to be the number that we should remove. So that is why the answer is E for this case. Because if you remove the 9, so 1 through 8 is just the sum of the 8 numbers. If you add them, you get 36, which is a perfect square. And all other numbers doesn't give us anything, so that's the answer. And here's the next problem, number 5. Okay, so Elijah, I guess, rolls 2 standard 6-sided dice, and she notices that the product of the 2 numbers she rolls is a multiple of 6. And which of the following integer cannot be the sum of those numbers? Okay, this is slightly challenging. So like 1 through 6, the numbers that we have for each die, right? So we probably can kind of list all the possible cases and see which one doesn't like achievable, which one is not the number we can achieve. So like one of them maybe we can try, like I can start with 1. If I start with 1 and pair with anything like 1 with like 1 is 2, 1 like the smallest number I can get 2. But if I kind of add 1 by 6, I could get 7. So anything between 2 to 7 is achievable. So like, for example, 5 is 1 and 4. So you could say this is achievable. And 6 is also achievable and cannot be sum of the 2 numbers. Let me double check. Actually, no, that should be multiple of 6. Okay, let me clear this mess. I was trying to add them. So it says the 2 numbers roll is a multiple of the product of the 2 numbers has to be multiple of 6. So like maybe we can try, like I can say 1 and 6. When you multiply, that's 6. So it means 1 and 6, like 2 numbers that she could have on the first and second die. And we are looking for the sum of these two. 1 and 6 is 7. So 7 is achievable if I choose 1 and 6. And if I choose 2 and 3, that is also 6. I'm trying to find the divisor of 6 in different ways if possible. So 1 and 6 and 2 and 3 is the only 2 ways. So if you add this, you get 5. So that's also achievable. So next multiple is 12. So 12 is like 2 times 6 or 3 times 4. And you may not do anything else. So this is 12 and this is 12. So the sum of these two is 8. Sum of these two is 7. So we were able to get another time. So the next number, like next multiple of 6 is 18. So I can say, I can use largest number like 6. So 6 times 3 is 18. And if I make this smaller, this has to be larger, so there is no other ways. But if you add these to 6 and 3, that is actually 9. That is also achievable. So this is the only number that I wasn't able to get it. So that is my answer for number 5. Okay, so let's see the next one. So Sergey skated around a ice rink, gliding along the different path. And gray lines in the figure below shows your path. Label those letters. What is the sort of order of the 4 paths from the shortest to longest? Okay, like this is a question actually, I would say one of the best ones, especially on the first 10. Um, so far, I would say at least, because it doesn't really like tell you what to use as soon as you read the question. But I think it just asking us to kind of realize the distances in different shape, like maybe using some Pythagorean or the circles and stuff. But let's see. So just take any two pictures. For example, when you have more like sideways like this, instead of just going straight around the corner, to see if this is longer than the other one. So let's say I'm gonna take this guy and take this way just to compare them. So if you just go all the way these corners and instead of doing this way, you know, you can just like think about this. Is this still longer than this path? Because this is the only thing is changing between these two. So instead of going this way, if you were going this way, it's actually longer path than this one. So which means if you are kind of going like diagonal path like this, you are making that path a bit longer than it is, right? So in this case, like if you are kind of taking this short path, that means this is going to be shorter than the other ones. So I hope that that makes sense. So based on this, I will say this is shorter than this, okay? So then R has to be coming from like before P. So I will say uh, like R is lesser than P. So that is something. So we have something right here, REP. So the PR, so this is not correct. So the like RP, so that doesn't work. And RP doesn't work either. Okay, so now let's think about the other two options left. So we have S and Q. So Q is right here, S right here. Maybe we can compare those as well. So, the corners are the same for these two pictures. But like imagine yourself, like if you were taking this path, only this path, instead of this like giggling around that. So you do see this line is gonna give us a bit uh shorter like distance compared to this one. So this is a bit shorter than this one. So it looks like S should coming before like Q. So it looks like the choice D is the best one. And let me double check with the other ones. So we have RP. Okay, so R is the shortest one because when you do have the curve like around this corner, so you are making longer. But if you are kind of taking this path in the middle, so you are making like a longer path. So this is why this was the longest one. So it is Q. So that's Q. And the next one is P. But if you compare P and S, like just ask yourself this way. So if you were to have a like diagonal like this, so this path, only this leg of the right triangle is shorter than this path. So if you are taking like this much, so that is way smaller than this much. So which is why this is gonna make our like path is longer compared to this one. So that's why this is gonna be the longer than the P. So P has to come in before S. So which is why D is much better. So I hope that makes sense. So I will move on. So the next one is 3 by 7 rectangle is covered without overlapping by 2 by 2, 1 by 4, 1 by 1 rectangles. What is the minimum possible number of 1 by 1 tiles that is going to be used? Okay, this is interesting question. So like, let's try and couple examples. So if you were to use this like 2 by 2, you cannot really split it. So this is like one of them you can. And if you want to just type like use one of them, so you probably want to use this a lot. So you could just use this one. Okay, 1 second. So let's say I'm gonna use 1/4. So if I wanna use that, I can complete this one either by 2/2 like this, or I can use another one like of this. So but if I use 2/2, let's say I'm gonna use 2/2 right here. Okay, so then there is no way to complete the remaining 3 and remaining 2 without using 1. So we just need 5 of them for sure in this case. So like if I want to try maybe adding this to here and then adding this to here, right? So now we have 3 right here, 2 right here, which is 5 still. So we do need that 5 still because there is no other ways to complete the given like diagram without overlapping. So which is why it looks like 5, but let's try a few other options to see. So let's say we want to use this one. We want to use this one. So we want to use this one. So this is 1/4, right? But for the remaining part, you can either go with this or just one. So you have to take at least 4 of these. So which is why still we are gonna left with 5 more. So there might be some better approach, but for now, this is the best I can do. So I will go with 5. Okay, so here is the number 8. So on Monday, the Tay has $2, and every day he either gains $3 or double the amount that money he had on the previous day. How many different dollars like a month could Tay have on Thursday, which is 3 days later? Okay, so it's not too complicated, but it says the number of different amounts. So we really need to like be careful because at some point you may get same result at the end. Okay, like if there wasn't asking like different amounts, like if the all the like combination is gonna give us different result at the end, we could just say every day you have 2 options, like you are either doubling or adding 3. So 2 option, 2 option, 2, which looks like 8 different results. I mean 8 results, but of those 8 results, we need to know which ones are different and which ones are the same. So since we have at most 8, so it's okay to list them. So let's start with 2. If this is 2, so the next day we could increase this by 3. So that will give us like 5. And then if I increase by another 3, that could be 8 and 11. So again, this is day 1, day 2, day 3. So I would say like it was like Monday, Tuesday, and Wednesday and Thursday. So this is one number. So when you start with 2, you can increase by 3 still, right? So, and then you may increase by 3 again. So that's 8. But now you can double this number. So that's 16. So now we can still increase by 3 on the first day. But now we can double this number, which will be 10. And we can now increase this by 3. So that should be 13. So 5, 10, and 13. So those are the one what I have if I start with 5, right? I mean, when I start with like increase by 3, I got these. So the result could be 3 different ways could be ended. Okay. So the next one, maybe I could just like double this number first, right? So because I can double the amount or add 3. So if I add 3, I got these numbers so far. But can I do have more than these? Like I can do more than these. If I do add like 3 on the first day, that's 5, double that. So that's 20, double that, that's, I mean, 10 and 20. So that is just the another one. Okay, so I think we have 4 already. If I start with 5, which means if I start with like increasing by the 3 on the first day, I have 4 different results. So other 4 should be the other one, which is kind of, we are on the same correct path. So if you double this number, so you get 4. If you double this number, you get 8. You double that, so you got 16. So that is just the another number you could get, but that's the same as this one. So if you double on the first day, you got 4. Now increase this number by 3, so you will get 7. You can increase by 3, which is gonna be 10, or you can double on the first day and increase by 3 and double on the next day. So you could get that. So we have one more, I guess. 1, 2, 3. So we can have double the first day, which is gonna give us 4. And we can double again, so that will be 8. And now we can increase this by 3. So that is 11. So far we have 1, 2, 3, 4. That is the same. 5. And then 14 is 6. This is also same. So it looks like we have 6 different results, right? So I have to be careful. So I think I count every possible ways to end this with. And because I was expecting 8 ways, so and then I list them all, and then that looks like we have 6 different results. So that was number 8. So let's see the number 9. So all of the marbles in Maria's collection, red, green, or blue. So she has half as many red marbles as green marbles and twice as many blue marbles as green marbles. Okay, so 2 different colors are compared with the green ones. Maybe we should choose variable for green. So I'm gonna say this guy has X green marbles, and which are the following could be total the marbles in that collection. Okay, so we are told she has as many, like half as many red marbles as green marbles. So if that's the case, I will say this has to be 1/2 X, and she has twice as many blue marbles as green marbles, so I can choose this guy to be 2X. So if I add all of these, I will get 3X plus 1/2, which is 7/2X. And this is my total. And from the choice, which could be this number, so like, it has to be multiple of 7. So it looks like 28, which is, if I plug 8 for X, right? So if I choose X is 8, so that will be 56/2, which is 28. So I think that's the case. So I hope I didn't mess anything, but that looks the answer. So number 10. So in January 1980, the CO2 level of 338 ppm, and over the years, this is increased by 1.515 per PM, so parts per million, whatever. What is the expected CO2 level in January 2030? Okay, so like in between this year to this year, there is like 20 plus 30, which is 50 years. And each year, the CO2 level is increasing by this amount. So we should multiply this 50 by 1.515, right? So we can multiply this by 10 first. So that should be 5 times 15.15. And that's just multiplication. 5 times 5 is 25. And then 5 times 1 is 5, plus 2 is 7. And then there's a decimal point. And 5 times 5 is 25, right? That's 2 leftovers to carry. So 5 times 1 is 5. That's plus 2 is 7. So it looks like we got this number. So let me double check. But the question was also giving us this. We had 338 ppm in 1980. So this is the change since then. So which is why we have to add this number, 338, to this number. So 75.75. So if you were to add this, so you will get 75. And that is 3. That's 1 to carry. That's 10. That's 1. And that's 413.75. So from the choices, the nearest integer is actually this number. And also, the other numbers are not too close to given numbers, so which is why we are confident with that as well. So that was the number 10. So I hope that was clear. So I'll continue for the next ones soon.